So welcome to this session. This is all about regulatory compliance today, the stuff we can all learn. This is not necessarily just for financial services customers. In fact, this session is all about exactly what it says here, which is what is it that the financial services industry have been doing and what can we all learn from that process. My name is Chris Atkinson. I'm a solutions architect for MarkLogic. I've been at MarkLogic for a couple of years now, and I specialize in the financial services industry. So we have a very, very simple ask from our business leaders. They want us to deliver this complete, accurate, timely view of our organization's data, which doesn't sound like too big an ask, right? But the actual challenge comes when they add this dimension to the question, which is, please don't break the business while you're actually doing this. And that's where the real challenge comes. Now, if you're going to do something difficult, and this is difficult, getting a view of your organization's data, then you need to look to the people who have done it before you. It's always better to look to the people who've already met those challenges, progressed down those challenges, they've done the hard learning, they've made the mistakes. And the reason why I have a space rocket, a Saturn V rocket, actually on the screen right now is because it's a great example of where that was done in the past. So the Saturn V rocket took man to the moon. And when America started that project, they decided that they would look to the experts. And can anybody tell me who those experts were? Did somebody say Russians? Germans. The Germans was the correct answer. And actually, basically the Russians, the Germans had been firing rockets at the UK for about 3 years prior to the end of the war. So they were absolutely the experts. So thank you, America, for learning at our misery here in the UK. But it's a great example of how you can fast track your own learning. And the experts in this case are the financial services industry. They have had some pretty hard times recently. Because of the financial crash, things changed. Huge changes in terms of what they had to report and who they had to report it to. So they've experienced 7 years now of tightening regulation, and it's getting tighter all the time. This problem for them gets bigger and bigger every year. They need to aggregate information across all of their activities. They need to be able to describe their activities, and they need to do that with an incredible level of accuracy. They also have an even bigger challenge, which is they need to do a lot of this reporting in real time. The very moment that a trade is created, that a contract is signed, they have to report some of this information. And they're seeing accelerating change. Now, that's all really important and very interesting. What makes them particularly different is that you can actually trust that they're doing it because there is an external entity that basically supervises this. And you can tell when they're doing it correctly because they're not in the news. And when they do it badly, they hit the news. So the reality is these are the Saturn V rocket builders of our current age when you're trying to look at getting a view of your data across your business wherever it is. Fundamentally, every single business, whether you're in the financial services industry or whether you're not, is moving towards ever faster rate of both data change and also process using that change. We are all moving towards a digital data-driven business, no matter which industry you're in. But how much do we really have in common? Well, before I answer this question, or this piece, just a quick show of hands. How many people in the room actually work within the financial services industry? Okay, so it's about 50% or so. So if you want to think about how much we really have in common, most of these particular pieces here, the 360-degree business views, the 360-degree customer views, are things we all want to achieve, okay? And that's because we want to use the 360-degree business view because we want to drive operational excellence. We want to drive out cost. We want to improve flow. We want to improve the general processes within the business. The 360 customer view means that we can market products better, we have better customer insight, we can create better products, we can target them better, we can see new gaps in the market, we can execute externally to the business more effectively than we've ever done before. That's why these 360-degree views are so important to people. The only then difference, perhaps, between the financial services businesses and the non-financials is that of regulatory satisfaction. And even then, we're starting to see more regulatory requirements creeping into the non-financials. And if you look at government, if you look at medical, for example, healthcare insurance, which is a subset of finance, you actually start to see more and more regulation in those businesses. But regardless, the 360-degree views are things that we would all like to achieve to drive our businesses forward. So what is the ask? Well, the ask is pretty simple, right? The data needs to be complete. These are familiar to any person who's done an IT degree is probably familiar with the 4 concepts of what good data looks like. It needs to be complete, it needs to be accurate, it needs to be flexible, and it needs to be timely. And I think of this as a value pyramid. You can't do any of these without satisfying the precursors. And ultimately, timeliness is the pinnacle of that pyramid, and possibly the hardest piece to achieve because it relies on all of the other pieces being done in a fast and efficient manner. So looking at completeness first. Completeness is actually an operational challenge. Gary, Joe, everybody this week has mentioned data silos. And we mention a lot about data silos because our customers are mentioning data silos a lot. And this is probably, this spiral diagram, if you like, is familiar to most of you, right? Which is, these are lines of businesses within your existing organizations, and I can almost guarantee, unless you're well ahead of the curve, that all of these different silos within your organizations are using different data models in different databases and within their own silos. The only difference with a financial services customer is actually the manufacturing the product piece. Well, that becomes even bigger, right? You start to break that out into even more silos. And actually, if you take derivatives as an example, derivatives can have their own data models for every single derivative, and the number of derivatives can be almost infinite. So financial services have kind of your problem, if you're not in financials, at an order of magnitude that is actually difficult to imagine. So they do have a big problem, but they're solving it, and they're solving it with MarkLogic. Now, where did the silos come from? In order to break down silos or to satisfy the outcomes of why you built those silos, you need to understand, well, what formed the silos in the first place. And silos fix a problem, okay? They independently, for each line of business, provide you with increased model flexibility. And it means because each silo, each line of business is responsible for its own data model and how it structures and stores information, it means that they don't have to interact so much with other people. They don't have to go through long change control processes to achieve change within their data models. So that means that they have a far more agile business model. They can react to their line of business needs. They can reduce cost. And also, very, very importantly, it's secure. It's a relatively easy process to secure a single database which your line of business has access to. Now, the problem arises that all of these lines of business, all of these separate silos inhibit the transparency of actually what's going on across the business. So we fixed it, right? We fixed that problem with data warehousing and using service-oriented architectures to multi-source data in a common format across your organization. But here's the challenge. Not so much a challenge or a good point, possibly, is that what you're aggregating and what you're publishing across your multiple sources is actually your known data. If the data is changing upstream, you might not be capturing that. The big problem is actually that you're decreasing the flexibility now of those systems. So by layering on the SOA on top of this, the service-oriented architecture, or by publishing to a data warehouse via an ETL process, you're now placing those change control processes back on that data, onto those lines of businesses. So this basically means that you go back through change control, you're introducing friction to data flowing through your organization, and you're increasing operational cost again. So ultimately what then happens is the business loses agility. So you've now got perhaps better transparency of your business, but you've lost agility. There is no guarantee of completeness because the information is spread all over the organization still, and you've no guarantees of what data was left behind. So what we need is a breakthrough concept. And a breakthrough concept is actually a well-defined concept in its own right. A breakthrough concept is defined as something which services a desirable outcome, which overcomes a previous constraint. And I often use an example of a canoeist who wants to get down the river fastest, okay? But the river's got rocks in it. So the canoeist with the paddle, he can go pretty quick down that river, right? But it comes a point where orders of magnitude, he gets fitter, he gets stronger, he gets more skill, and he gets to a point where he can go no faster down that river. So we can start thinking of some imaginative ways of making that canoeist go faster. A jet-propelled canoe, for example. The problem with a jet-propelled canoe is it's going to hit the rocks because he still needs the agility to move around the rocks. So even if I start putting faster and faster mechanisms on the back of his canoe, bigger paddles, all this sort of stuff, he still hits the rocks. QED, what we need is a breakthrough concept, the hovercraft. Okay? The rocks are still there. I'm overcoming the constraint by producing something which overcomes that constraint but satisfies my outcome. So if we look at the outcomes and the constraints associated with silos, we want to increase, the outcome is I want to increase business and information agility at a departmental level, but I also basically want to increase actually transparency across the organization. The constraint is that single schema and single model databases actually inhibit that flexibility. So what we actually need, very, very simply, is a multi-model database, which allows us to store multiple models in a single location, which satisfies those. There is your breakthrough concept, and that is Mark Logic. So we provide that in a very consumable form. We provide you with increased model flexibility, a single database for aggregating the information across your organization. That means that you break that change control cycle. And very, very importantly, we actually provide you with a level of security that guarantees that the information held within the database, even though you're aggregating it, is still secure from the other LOBs, from the other consumers of that data, should you choose to do so. It also means that we now have improved agility and we've reduced cost. It's a single location. All of the SOA publishing now goes out the window. Having to republish to a data warehouse is also eradicated. The business, they win too. It's a single location. The data is published into this area. We're not doing ETL processes. We accept the information as is. We publish it as is into a central location. Everybody wins. So an example. So I can see if 3 people in the audience who this might be familiar with. MiFID II. So MiFID II, for those of you who don't know, is a regulatory requirement that is fast approaching for many of our customers. It's probably about 18 months to 2 years away to be delivered. And this is actually an example of where we're taking information in multiple models and placing it into a single trade store. So here we have 2 different sources. There's actually many more sources than this, but I'm just using 2 as an example. And this I would describe as fast data. Fast data being trade data, thousands of trades per second. We have several trade stores customers, and some of those accept thousands of trades. Some of them actually accept hundreds of thousands of trades a second. Very small, typically in size, sometimes just 2K in size, but sometimes up to 1.5 meg in size. But ultimately, 2 different trade types, 2 different data models stored within the database. And then we have this slow data, which is actually coming in a different form. This is a CSV format. It's called reference data. Reference data is used to store information about the world around us, or actually, in fact, the world within our organization, HR data, personnel data, that kind of thing. And you can see here, within there, we have Murex trades, FixML trades, and reference data, all very different data models. And we can do that because when MarkLogic ingests information, it looks at the inherent structure within the document, and it derives the schema from that. So what we have here is actually an example as well of the common attribute across these. Oh, this doesn't. It works in the ceiling. That's not very useful. Counterparty ID, counterparty underscore ID, and the CPID. These are attributes that mean the same across these different data models. So not only have we got data within here, but actually at the point of query, what we are now able to do is, click back. We're able to join those different data models together at query time. So this is where the flexibility comes from. Multiple models in the same database. We're not changing the data, we're ingesting it as is. Very powerful and very simple. So this session is about lessons learned, right? Some people in the room may be familiar with MarkLogic. So one of the big tips I've got right now for if you're going to be doing this kind of work is all about materializing. So materializing is effectively doing some work up front to save resources, time, processing later. A lot of our customers typically run end-of-day reports, batch processes, end-of-day calculations. And what that means is that over the period of the day, you may end up with a fairly steady load, and this is a typical kind of load for a trade environment. But then you get to the end of the day and the trading closes or your end-of-day processes start, and you have a huge spike in workload as you start to do joins, calculations, all this kind of good stuff. So materialization is a way of trying to avoid this because dealing with that spike is expensive. For the rest of the day, everything's effectively using maybe half those resources, and what we really want to make sure is that you use less resources to achieve your outcomes. So the lesson is really around materialization and something called the envelope. And if anybody, how many people went to the data modeling workshop on Monday? Okay, so you guys are real familiar with the envelope by now. Okay. If you're not, then there's lots of information on our websites about it, and also the data modeling workshop, I believe, is downloadable. So if we take an example here, we have a trade that comes in, we validate it, and what we see here is actually, three trades. We have the Murex trade, the fixed trade, and the reference data. And you can see here we've highlighted some of the attributes within that trade. Okay, we've got trade ID, trade underscore ID, and CPID. We also have something in there called rating highlighted in blue. Now, the stuff that you want to materialize is stuff that is typically really expensive to do. Now, if you think about a trading environment, a trade is not a single event. It's actually multiple events that go through a timeline. So a trade is agreed, it's contracted, it's settled. There's actually up to multiple steps. And there's a lot happening. For any database, group by and then sort to get the last version of that particular trade leg is a big consumer of resources. So that's probably at the end of the day where we're going to be spending most of our resource time, so we're going to target that. But also we're thinking of static calculations. Are there calculations that when we're ingesting the information we can do right there and then and store them within the document? And in this case, what we do is we materialize this. So we create an envelope, that's a wrapper around the original trade, which you can see here in the Murex trade example is still there. It's immutable. We've not altered the data. But what we have created is a new kind of sub-area, some metadata under the synthetic heading, or the synthetic nodes there, and it says last ver and rate calc. Last ver is calculated on ingest to identify whether this is indeed the last version of this trade, is it the current? That means we don't have to do so much group by and sorting anymore. And the rate calc is actually a calculation that we calculated on ingest, and MarkLogic is very effective at doing that. So this is an excellent example of materialization to reduce the query load, reduce the joins that you're doing at query time, and also perform some of those calculations up front. For everything else within that trade, so all the other stuff within the Murex trade, you can still access it at query time. We've not restricted that. You've just got the best of both worlds. And that means that when you start looking at the impact of your actual capacity and basically computing requirements, you've removed a huge spike from the end of the day, you've distributed it more evenly. It's a much more effective and scalable method of deploying any database, and especially MarkLogic. So that's completeness. But what about accuracy? So accuracy is a huge problem. Most people in the room, I would guess, would be happy with something like 99.98% accuracy in their home accounts. Is there anybody here that isn't happy with that kind of accuracy? Rodrigo, really? That means that you must have a lot of money then. So the financial service industry, 99.98 is not good enough. There was a bank last year who was fined $40 million for achieving 99.98% accuracy of their data. And that's because when you're processing hundreds of thousands of trades a second, then that still means that you're getting hundreds of thousands of things wrong potentially over the year. And that is how financial markets can be destroyed. So accuracy is super important. And I'm going to focus on two areas of accuracy. The first thing is about the congruency of the data within your environment. And congruency, or the data, the congruent type of data that you're storing, is really about, am I seeing exactly the same information across my organization at the same time? Is everybody working from the same data? So we typically use ETL processes to move data around, and we publish it around, especially with service-oriented architectures. And we shard the data up from our upstream sources, and we then ingest it down into warehouses. That's how we typically do it. We also, though, need to make sure that we store the outputs of the calculations, or we perform the same calculations in the same manner. If I'm performing different calculations across the different sets of data in different places, I need to make sure everybody is using the same calculation across the same data. We all know that we can cut data in different ways. The other side is temporal. Now, I'm going to be talking about temporal this afternoon, later on in my lightning talk, just before the keynote, so I'm going to cover more of it there. But temporal is about accuracy. It's about understanding the accuracy of data over time and how it has changed over time. And it's to do with correcting. If something is corrected in time, then that needs to be presented to you. So it is not versioning. Versioning is very simple. Versioning means I have a version, I have a version, I have a version, whereas temporal means that I'm actually going back and correcting information back in time. And an example of this is where I have a bank balance of $1 million, I wish. I cash a banker's draft into my account for $1 million, which takes my bank balance up to $2 million. However, if I don't find out, but basically the draft turns out to be invalid, it was a fake, but I don't discover it for another period of time. So if I run the query at the end of this process and say, what was that vertical line where it intersects the bottom, what was my bank balance at that time? Well, I know now, looking back, that actually my bank balance was $1 million shy. However, I also want to ask the question, what at that time did my bank balance look like? Then at that point in time, then it was 2 million. So it's about answering with the fidelity and accuracy what you knew at a given point in time. So the challenges are pretty monumental in this regard. So the biggest problem with ETL is that you've no guarantee you're getting all the data. Because every time you pick data up, you take it out of its relational tables, you package it up into objects, and you send it across the wire, and then you redeploy it down into wherever the target system is, there's no guarantee that you're getting all of the data. So that creates problems, and it's such a monumental problem that some financial institutions, not too distant from here, have over 500 people working on reconciliation problems every single day of the week. And that's how people fix it. They basically look at the upstream systems and they basically run reconciliation jobs to identify that everything is there, and only by running that reconciliation job are they able then to produce the data. And you're always going to have to do this, whether it's MarkLogic or another solution, you're going to have to run reconciliations because you need to map. But this becomes particularly challenging because in a rigid data model, if the data doesn't fit because somebody's changed something upstream, then it's just rejected because you can't fit an ill-fitting data model into another data model. So that means that you've got to try and identify what it is that was rejected from your exception queue and then re-request it upstream. It would be much easier to do this in place. And temporal, well, I'm going to mention more, like I say, more of this afternoon, but temporal also has a big issue, and that is that over time, schemas change within databases. If I want to know what I knew at a point in time, and there was a schema change, then I need to basically reapply the queries that I ran at that point in time through the schema of the database at that point in time against the data in the database at that point in time. And that's difficult to do within a relational model. It is not easy to manage that kind of schema, a change over time. So the ways people typically deal with it, the most common approaches are to, every time somebody runs a report or a query, is dump the result into another database as proof. That's okay. It's okay until you want to find out what happened between reports and queries. And most regulators don't want to know what you reported. They want to know what you knew at a point in time. The other approach is to use infrastructure tooling, backup, recovery, flash backup technologies in order to basically spin up a new environment, have all of your data in it, and roll the database back to a given point in time. And if that sounds expensive and time-consuming, that's because it is. So MarkLogic helps. Okay? We help in a number of different ways. I'm going to take another trade store example of a risk aggregation solution. So we have multiple sources pumping data into the trade store. Now, the first thing that happens is we check for duplicates and we check for validity. Now, we check for duplicates because typically within an environment, you're going to be consuming data from an enterprise service bus or from an MQ server somewhere. There is every possibility that you may end with duplicates coming from your upstream systems. So hash check those when they arrive to make sure that they are in fact duplicates. And if they are, just reject them. There is no need to ingest duplicate data. However, if it fails a validity check, then what we do is we still accept the data. And we can still do that because we accept any data model. We're not rigidly defined on what we appropriate. But we raise an exception. And that means that we can now do the reconciliation process, the fixing of this, with the data in the database. We can see it. We can touch it. We can either fix that data in situ and notify the upstream processes, or we can notify the upstream processes and have that data come back through again. Bottom line is it becomes very, very much easier to reconcile in situ than it does elsewhere. That becomes particularly relevant if you're reconciling across multiple different sources. Perhaps the reason why the exception has occurred is because the customer ID does not exist in the reference data. Well, it's much easier then to have all of these other sources where that customer ID exists in the database and then fix why it doesn't exist in one of them later. That is the power of doing reconciliation in place. Now, if you take another example, which is the approach of where do I perform and store my calculations, let's take an example where a customer now wants to update some information within the database, and they want to do so on a piece of information that's particularly large. Some derivatives can actually last for tens of years. There are trades within one of our customers' banking systems that actually predate the war. So there's a lot of information there. So these are quite large documents. And if you've got a lot of these large documents, so there's a lot of activity on a particular trade contract, then you might not want to be updating the original document. That's costly. There could be tens of megabytes, in fact, of information. So it's a much more effective method to publish that calculation back into the database so everybody can see that calculation, but not do it to the original document. We can create a linked document. And that's very efficient because we're now just storing the size of the trade of the calculation. And if you want to get super efficient, then what you can do is you can use our RDF technology, which creates a triple that we attach to the original document. And that allows us to store just that value. And if you know how triples work, they effectively have subject, object, predicate, and they describe a relationship. But they can also be used to describe an attribute. So we could say in this case that trade ID whatever actually has rate calculation and then the value. And that becomes very, very efficient for us to store and query. But everybody now is working from the same data and the same calculation. So data quality is preserved and it works very well. All of this is wrapped within our bitemporal API. So if I want to run different queries through here, I want to see what I ran at a point, what I knew at a point in time, then I can do so very easily because we wrap this whole construct inside the bitemporal API, and I'm going to talk more about that this afternoon. So that's it. We've done completeness, we've done accuracy, now it's flexibility. Now I come from, before joining MarkLogic, I was very much on the operational side of storage, availability, and managing data at a lower level than doing it at the database level. So the one thing that I was familiar with, and I know that everybody in this room is familiar with, is the pain of change control. Okay? So change control is a convoluted, painful, and expensive process. And the way relational databases work and how we look at that warehousing and SOA architecture is very similar, but I'm going to take the warehouse architecture example as when a consumer knows there's information in the source system or wants information published or captured within the source system, they'll create a request. That request goes to the source system, and the source system will either start capturing that data or define a data subset around that. They will then request that the data warehouse reflects that change. So the warehouse indexes are updated, the structure is created, the model is prepared. The ETL processes that link all of the solutions together are now updated to make sure that that information is pushed through. And then ultimately, when that all is done, we can start pushing the information to the data warehouse. And when that's complete, we re-index it. And finally, we can get to the point where we're reporting the data. Now, the big problem with this is there are a lot of steps and quite frankly, a lot of junk between the consumer and the source. If we want data to flow quickly through our organization, if we want to see new information as it's generated, we need to bring these two closer together. So empowering your consumers is all about basically bringing those two pieces together and reducing the amount of change control. And it's relatively easy to do that with MarkLogic. So we introduced two new concepts. The two new concepts are fixed attributes and dynamic attributes. So a fixed attribute is something that is highly unlikely to change within your data model. If I go to a doctor's, if I go to hospital, then the one thing I can guarantee that they always take off me is my name and my date of birth. While I'm being wheeled into surgery, wheeled out of surgery, I've had a lot of mountain bike accidents, I'm familiar with this. They ask you those two things, time and time and time again. What's your name, what's your date of birth? It's a great example of a fixed attribute. It's unlikely to change. So what we do is we take those fixed attributes, and what we do within MarkLogic is we create a concept of what we call common attributes. And we take the fixed attributes that are used all the time and we combine those across our multiple data models. So now what we have is the common attributes, things that mean the same things to people across all of the different data models that we're hosting. And then we have the dynamic attributes. Those are things that are liable to change, the flesh. They may not be common across any of our different data models that we're hosting within the database. I often use the analogy of it's like an apple core. Okay, or an apple. You have the apple, the flesh of the apple, and you have the apple core. The common attributes are the apple core. Everything hangs off those attributes. It's the stuff that basically, if somebody runs a query, it's the dimensions. It's the things that you use to derive the information. The flesh of the apple is the dynamic attributes. That's the stuff that can change. It can grow, it can shrink, it can change over time. So consumers, their calculations, their decorations that we just discussed, they store all of that new data inside the dynamic attributes. We don't need to map that. We can adjust it on the fly. It's actually determined by what people put into the database. But when people query this, when they run their queries against this, the common attributes are the dimensions that they will typically use, but the dynamic attributes they can also use for dimensions as well, but it becomes a very, very simple approach for them to understand exactly how the data is pieced together, and then where all the flesh is. We don't need to reference new indexes. We don't need to publish new data models in order to surface the information from our consumers and push it all the way through, from our sources and push it all the way through to our consumers. So what does this look like? Well, and what are the big tips? And that's the key point. So the first thing is I'm going to take an example here. We have the Murex trade and we have the FixML trade. And what we can see here highlighted in the blue are the fixed attributes. These are things that are unlikely to change. Underneath that, you can see all of the dynamic attributes, and you can see there's no commonality here, and nor do we need to agree it. So what happens is we turn those fixed attributes into materialized common fixed attributes. So you can see now we've actually created common elements. CPID represents CPID and counterparty. We've actually created these on ingest, and executed is now executed and date. Now this has a big, big advantage within MarkLogic. And that is that the data model, this materialized element stretches through our entire data model potentially. And we can place a range index against that. And a range index is a highly performant memory-based construct within MarkLogic, and it's hashed. So if it goes all the way through our data set, it becomes incredibly efficient in terms of memory usage and also performance. This thing flies, like no mistakes. But we've also anchored our data model. It's much more easy to understand how this data actually moves and floats around this core attribute area. Now, the next question, or the question a lot of people have in their minds is, brilliant, I'm going to use this across every single attribute. Don't. Because if you do, you're now forcing yourself down the same route as relational, which is pre-mapping all of this information. You don't need to do that. So you basically just target the things that you need to. So things that are ordered lists, things that are common throughout your entire data model, across all of the different data models, or things that you commonly join with. Those are great, great things to create inside the common attributes and synthesize and materialize at the point of ingest. Okay? If you want to take it to the next level, then what you can do is you can take those common attributes and you can create RDF around them. You can basically say, this particular common attribute is related to something within my data model, my enterprise data model. And I can do that across all of my different sources. So now I can basically say, look, here's my enterprise data model, and it's mapped in such a way. And I can then map those entities within my trades or my documents back to that enterprise data model. And I can in turn map that to a reporting ontology. And now you have the makings of an extremely flexible enterprise data model. And that means that you can rapidly change your reporting and surface your reporting across your organization. This is unique to MarkLogic. There is no other solution out there that combines both RDF and also document power. And finally, timeliness. So timeliness it's the pinnacle of the pyramid. You've got to get everything else right before you can actually get to deliver timeliness effectively. But there is also an additional feature that MarkLogic brings that accelerates this even further or delivers a particular value. And that is the ability to do real-time reporting with a feature called reverse queries. Now, reverse queries are able to exist because of the way MarkLogic works. When a piece of data arrives in MarkLogic, when a document arrives, we index it and we store it. That means we know what's in MarkLogic all of the time. We don't have to go and look at information specifically to derive a query. And that means we can do something pretty funky, which is we can set queries up, and we can basically, if the query is matched, we can then trigger an event, in this example, a REST call. And we're able to do this across all of those matching reverse queries very, very efficiently. Now, most people who are familiar with relational databases will be familiar that triggers are expensive, very expensive. Most people will try and solve this problem in an application layer. MarkLogic, we have customers who run thousands of reverse queries. It is an extremely performant way, and it's just because of the way we do this reverse indexing. Very, very efficient. It means that you can actually now trigger events in real time when they meet certain rules on the ingest queue. Very, very effective. So I'm going to open the floor up for some Q&A just for 5 or 10 minutes, and then I'm going to wrap up at the end. So I'd ask what questions you have. Any questions at all? Going once? Not one. Please ask a question. Okay, once, twice, no? Okay, well that was a fast Q&A. I've either done a great or a terrible job. So in summary, MarkLogic are, I believe I'm saying this, the Saturn V rocket specialists of the database world. We will take your database to the moon. Maybe not precisely, but it's great, similarly. We provide you completeness. No data is left behind. We ingest information as is, but we don't leave it as is. Remember that. We actually adjust that information, materialize things in order to make it more efficient. We're accurate. The information is stored and aggregated within a single location. We're able to store the calculations as well, but we're able to do that in a highly optimized manner. And it's flexible. We're actually empowering the consumers. We're bringing the sources closer to the consumers, and we're removing a lot of the strictures of ETL processing that you're typically experiencing within the relational world. And then finally, timeliness, the pinnacle of the pyramid. You've got to get everything else right first. We deliver that, but we also have the advantage of the particular reverse query technology that allows us to fire off real-time monitoring as well. So thank you very much for your time. If you're interested in learning more, then you want to start integrating your science today, please follow this link or contact me, Chris Atkinson at marklogic.com. Thank you very much.